Hello students, it's Mr. Win here. Today I am going to show you how to solve similar right triangle problems using a method I have created over the years, and it's called the 3 by 3 table. But first, let's talk about where we get these similar right triangles. There's a theorem that says that if you draw an altitude um, from the right angle um, perpendicular to the vertex, not perpendicular to the vertex, perpendicular to the hypotenuse of a right triangle, then you form two other similar right triangles, as seen here in this depicted diagram. Anyway, so comes with that several segments that we are gonna have to be able to find, right? So first, we have the hypotenuse of the big picture of the big triangle on the outside, right? The big triangle, we have the hypotenuse, and this altitude cuts that hypotenuse into two pieces, mainly the long piece and the short piece, right? Um, and then, so those are the blue pieces that we're probably going to have to find, right, in some of these problems. Then we have the short leg of the big triangle that we're going to have to be able to find. We have the long leg of the big triangle that we're going to need to be able to find. And then lastly, the altitude. So all of these little pieces of segments we have to be able to find. So, and it gets very confusing. There are theorems that help you find these things, but uh, the problem with theorems is that not a lot of people remember them or have them memorized, and they're like formulas that you have to use, right? So not they're not readily available in your head, so that you can solve these problems quickly. So over the years, I noticed my students have difficulty recalling facts about how to find these things. So I developed a 3 by 3 table. So we're going to take a look at that right now, okay? And how we can use that to solve um, similar right triangles. Any of these segments you can find using this table, okay? And what this table does is it helps you set up the proportion, because these similar triangles have proportional relationship with the segments, right? So the table is just helping you organize all the information so that you can get a proportion that will help you solve, right? So here's an example. This one is a simple example, and this one actually has a theorem that you could use. Um, but it's the geometric mean to find the altitude of the similar right triangle. But that's in another lesson. Today, we're not going to talk about geometric mean. We're going to talk about this 3 by 3 table, right? So what I do is I organize them as um, on the left column, as you can see, I organize the triangles by size, right? We have a small triangle, the medium triangle, and the large triangle. Well, the small triangle, according to this one, is on the left side, right? And then on the right side would be the medium. Now, each of these triangles have a short leg, a long leg, and the hypotenuse, right? So the small, if you look at the small triangle here, ABD, you can see that the short leg is 9, the long leg is X, and the hypotenuse is not given to us, right? It's like blank, right? So we're going to fill in this table just like that with the given information: 9 for the short leg, X for the long leg, and blank for the hypotenuse. Blank just means there's no value there, it's useless, I can't use anything, I can't do anything, I cannot use segment AB to help me find anything, right? So I leave that blank. Now I'm going to move my focus to the medium triangle. So the medium triangle, the labeling is still there, right? The medium triangle happens to have a short leg of X value, right? The long leg of 27, and then hypotenuse again is unknown. So I'm going to do X 27 and then blank, okay? Now I'm going to shift my focus to the very outside right triangle, which is the whole thing, right? So the whole thing has a short leg of nothing, the long leg of nothing, and the hypotenuse of, well, you can add the hypotenuse of the long leg by adding you can find the hypotenuse by adding the short piece and the long piece together. So 27 and 9 would make 36. Well, if you look at the large triangle with those two blanks, it's not going to help much. And then if you look at the column where it says hypotenuse with those two blanks, it's not going to help much. So our proportion actually comes from the 9 and the x and the x and the 27. And the way they are written, those those are ratios, right? So we can do 9 over x equal to x over 27. Because the ratios are equal to each other. That's what proportional means. So we set up that proportion, and oh, sorry. And by this time, you should know what to do, right? Because you learned how to solve proportion this way. We cross multiply x and x, and we get x squared. We cross multiply 27 and 9, we get 247. Now, you have to solve for x, so we got to take the square root on both sides, right? So the square root of 243 is not a nice number, so what we do is we simplify this square root into square root of 81 and square root of 3, and then we get 9 root 3 as our final answer in the exact form, right? The radical form. I do have another video showing you how to simplify these radicals using your graphing calculator. So if you want to check, I'm not going to mention that here. So if you want to check that video out, you're more than welcome to do that. It's in my channel as well. So anyway, that's our answer, right? 9 root 3. It's the measure of x, okay? And you can type that into your calculator if you want a decimal value. Later on, we'll see the decimal value. Okay, let's try another one. This one looks a little bit more complex, and students usually struggle with this when there are measurements that are thrown in there and they can't figure out which is which, right? And they don't know. They don't have the problem with this is that they can't use the theorem because they don't have the pieces of the hypotenuse, right? The last problem we did, we had the pieces of the hypotenuse. We had 9 and then we had 27. We could have used the theorem, but on this one we can't use the theorem, the geometric mean theorem. So now we have to have some other proportional relationship set up. But that's what this table is for. This table will help you set up any proportional relationship with these three triangles, okay? So again, small, medium, large, short leg, long leg, hypotenuse. So let's look at the small triangle real quick, okay? I've highlighted for you, and it's a good idea when you do these, you highlight them as well, okay? So the short leg is the short piece of the hypotenuse. In this case, it's EF, right? It's EF, but then we don't know what it is, so I'm gonna leave it blank. Right? The long leg is the other leg of the right triangle, which is x, and then the hypotenuse is 6. So if I were to fill out that table, it's going to be blank x6, blank x6, okay? Blank for short leg, x for long leg, and then 6 for the hypotenuse, okay? Now shift your focus to the medium right triangle, which is the one on the other side. The medium triangle has a short leg of x, which is the altitude, because the long leg is the long piece of the hypotenuse of the big triangle, right? So long leg, long piece, short leg, short piece, okay? So the short leg of this medium triangle is actually the altitude, which is x, and then the hypotenuse is 8. So if I were to fill this table out for medium, it would go x blank 8, x blank 8, okay? There you go. Now, if you look at what we've filled in, there's no proportion for us to solve, right? We can't do x over blank and then 6 over 8. That's not going to help us to solve anything because blank is blank, all right? So now I have to resort to my large triangle and fill in that table, hoping that I'm going to come up with some sort of proportion, right? And you will. Okay, let's shift our focus to the large triangle, which is the one on the very outside. The short leg is 8. No, not 8. Short leg is 6 because 6 is less than 8. So make sure you put in the right values, okay? Short leg is 6, long leg is 8, and hypotenuse is 10. So 6, 8, 10 goes in that order, okay? Now, do you see your proportion? Okay, there are two options here. You can do x over 6 over 8 over 10. It has to match, okay? So medium match to large. You can't do medium and then small over here. You cannot do x over 6 and then x over 8. That doesn't work, okay? Or you can do x over 8 and 6 over 10. Okay, those are your choices. Okay, as long as they match up. Okay, because the ratio have to match. Okay, so I'm gonna use x over 6 and then 8 over 10. Okay, so that's my proportion. Cross multiply, I guess 10x equals 48. Then I divide by 10 to get 4.8. So the altitude of this triangle, which is segment DF, is equal to 4.8, whatever unit it's. All right, let's try another one. We're going to get to a one that's a little bit complex, right? So in this problem, we get two variables. That means there are two segments that they want us to find, okay? So you're going to love this table because it doesn't matter how many variables they throw in there. As long as you can set up your proportion, you can find them, okay? So let's do this. Let's look at the small triangle, okay? So the short leg is 4. The long leg, I don't know. So it's blank. And then the hypotenuse is x. So 4 blank x. 4 blank x. The medium triangle, which is the yellow one there, I highlighted it for you, or green. Short leg is blank. Long leg is 20. Oh, actually, nope. Long leg is not 20. 20 is the whole thing. So long leg is actually the rest of that, right? So it's 4, and then the whole thing is 20. So the rest of that must be 16, right? So the long leg for this one is actually be 16. I almost fell for that trick. So it's blank 16 and then y. Okay, blank 16 and then y. Finally, the outside right triangle. We have short leg being the x variable, long legs being the y variable, and then of course the hypotenuse of that big triangle is 20. So x, y, 20. Okay. Now, if you look at your table, all you have to do is match up these ratio. You have 4 over x and then x over 20. That's one of them. You could use that to solve for x. There's 16 over y and then y over 20. Doesn't matter which one you solve for first because those are independent, right? I'm going to solve for y first just because. All right. 16 over y equals y over 20. Cross multiply and then take the square root and then simplify your square root, okay, into 8 root 5. And then once you find something, go ahead and replace it in your table, okay, because that variable is now been found. So you put the value in for your table. And then now use the other proportion to find your x variable. So 4 over x equals to x over 20, okay? And then cross multiply, simplify the square root to 4 root 5. So x is 4 root 5 and y is 8 root 5. Okay, easy. All right, let's do another one that's actually harder. This one we get 3 variable. So how are we going to deal with a 3 variable similar right triangle problem? All right, well, use the 3 by 3 table. Fill out your small triangle. It's going to be, by this time you should be familiar with how to fill this out, because if you're consistent, it's going to be the same every time. Short leg, long leg, hypotenuse, right? 24, 32, and then y. Okay. Um, medium triangle, 32, and then x, and then z. All right. And then big triangle on the outside. Oh, before I do the big triangle, I want to go ahead and find x, because I do have a proportion there, right? So I can just cross multiply those and then find my x variable, okay? So I'm going to do that first, okay? Get it out of the way, okay? 24 over 32 equals 32 over x. Cross multiply is 24x equals to 1024 because that's 32 times 32. And then you take that and you divide by 24, you get 42.7. So x value is now 42.7 in my table. Okay. Now I have y and z left. I can't use that to solve for neither one of them. So I'm going to have to go and fill out my large triangle. So the large triangle, notice its long leg, short leg is y, long leg is z, and the hypotenuse is x plus 24 because that's the whole thing, right? So there is my large triangle. Now, with respect to x, I've already found it. So I actually could fill out the hypotenuse of the large triangle with 42 plus 42.7 plus 24, which happens to be 66.7. So I could actually replace that with that, right? So that's why you want to replace all the values or the variable in your table with actual values that you have already found, because it's going to help you find the next variable. Okay, as you can see here, the z variable can now be found by using those two ratios, right? So if I set up that proportion, I can find my my z value. So I'm going to do 42.7 over z equal to z over 66.7, and then just cross multiply and take the square root. Okay, so the square root of 2848 is 53.4. So now I'm going to actually go back to my table and replace 53.4 with z. The last one I have is y. Okay, there are multiple ways to do this. You could actually use this table to set up a proportion for y. But if you look over here on your drawing, y is actually the hypotenuse of a small triangle where you already know what the legs are. So if you know what the legs are, you could use the Pythagorean theorem to find the hypotenuse, right? And that's actually probably faster than using the proportion, because look at all these numbers. They're not very friendly numbers, right? And if I were to do a proportion, it might take me longer. I don't know, either way. So but I see that I could actually use the Pythagorean theorem here, so I'm gonna go ahead and do that. I'm gonna do y equals 24 squared plus 32 squared, and then I take the square root of that. I get 40. So my y variable here is equal to 40. There you go, guys. This 3 by 3 table, I think, is very useful for solving similar right triangles. So I hope that you guys enjoy my video. Uh, if you like it, click the like button and subscribe to my channel for more math videos in the future. Thank you for watching, and I will see you next time. Bye bye.